Hi everyone, my name is Shimon Tolts and it is great to be here at DevOps Days Buffalo. Thank you very much for having me. And today we're going to talk about how to manage policies in a centralized way at scale. And I'm going to use Kubernetes and some policies around managing clusters and configuration as an example. And we're going to talk about what are the best practices and the things that we've learned regarding what is the best way to manage centralized policies at scale. So let me share my screen here and I'll share my presentation. So this is going to be a very much hands-on with examples, real-world scenarios in terms of our examples. So, centralized policy management and scale. So, first of all, it is very nice to meet you. My name is Shimon Tolts. I'm 32 years old. I'm based out of Israel, and I've been dealing with the DevOps and infrastructure for more than 10 years now. I was the general manager for the infrastructure division at a company called Iron Source, which recently IPO'd for $11 billion. And also, I'm an AWS community hero. I lead one of the largest AWS communities worldwide with more than 8,000 members. So we geek out a lot about how to manage DevOps and infrastructure and how to delegate responsibilities to developers. And this is some of the things that we're going to talk about today. So, first of all, what is our or my experience in this field? So we are at the tree. We help prevent misconfigurations from reaching production in Kubernetes workloads. And why am I telling you this? It is to show you that we have many customers, actually more than 250 companies that use our solution in production and actually manage policies in a centralized way through our engine. So it's an open source CLI which you can get at GitHub. We just passed 2,500 stars, so I'm very, very proud. And it's at the trio/the tree. And what it does, it scans every code change that a developer makes, and it then identifies misconfigurations, and it actually blocks the changes from reaching production. So from doing so, what happens is that we integrate this into production, and developers are running it on their laptop and also in their CI/CD pipelines. So we get to see a lot of Kubernetes and policy management at scale. And we also read a lot of postmortems and talked to many companies that manage those manage those types of workloads. So let's get deeper. So I'm going to show you an example of where is my screen? I lost my screen. Sorry. So I'm going to show you examples of policies that you would want all of your organization to follow, and then we're going to talk about the core principles of how are you supposed to propagate those development standards and how to manage a centralized policy at scale. So I'm going to do this. First, we're going to go over 4 mistakes that are very common in Kubernetes, and it's going to be a little game show, so you can also guess and see. And then we're going to talk about how to manage them. So first off, we're going to talk about some Kubernetes cron job workloads. So let me just get my laser pointer here. So as you can see, this is a file. It's a cron job, and there's a scheduler and deadline seconds and concurrency policy. And you need to guess what is the mistake. Is it the API version? Is it the scheduler? Is it a concurrency policy? Or maybe it's an incorrect YAML structure. So the answer here is that the problem is with the concurrency policy because it is set to forbid. And what happens when you set this policy, it is set to allow instead of forbid. And what happens in this case is that this actually cron job scheduler is set to run a job every 1 minute. And what happens here is if the previous job hasn't finished, it's gonna spawn a new one and a new one and a new one. So this is actually something that happened to the company Target, and they spawned more than 4,000 pods because they had an error there, and it just the cron job workload keep spawning it. So number one, don't trust the default configuration, and make sure that the configuration that you have is actually suitable for your workload. So maybe this concurrency policy is great if you run, if you run something once a day, but in their case, they wanted to run something every 1 minute, and then it cost 4,000 containers to run. Secondly, we have another mistake here, which is also related to cron job. So we've learned that the concurrency policy in some cases should be set to forbid, and it is this way. So what is the problem here? Is it the restart policy? Maybe there is no mistake. Is it the concurrency policy? Or is it an incorrect YAML structure? So in this case, what actually happened is that the configuration was placed in the wrong place. So what happened is that actually there was no configuration because it was in the wrong place at the YAML in terms of YAML structuring. So actually this configuration did not propagate to the cluster itself. And what happened is that this setting did not go and did not get applied to the cluster. So what happened is that an API server was running out of memory because it continuously spawned pods. And what we can learn from here is that it's not only important to know what is the right configuration to put, it is also important to know where to put it in place. And this thing happened actually to Zalando. So in this way, you can define policies, and you need to define them for your organization. Let's move on to the next issue. So the next issue here is that we have a pretty simple ingress workload. And, out of the blue looking at it, it seems pretty much okay. But the mistake here actually is that the host is set to star. And what happens in this case is that all traffic is getting routed into this ingress controller. And it is actually accumulating all the data, all the traffic from other loads. So this thing also happened to target. And what you have to do is to delegate the knowledge for your for your developers in order to, of course, use the configuration in the right way. And the final example I'm going to show you is this pod configuration, which, by the way, seems very, very simple. Like, what's so special about it, right? So the problem here is actually not with something that is written, but rather with something that does not exist. And this is the thing that there are no limits set here. And this is very dangerous because if you have no limits for your workloads, your cluster might run out of memory, or you might have a CPU issue. And this happened to a company called Blue Metador. And by the way, all of those postmortems are like public, and they're publicly speaking about it, so I have no problems to show them. But in this case, they brought a third-party container, and this third-party container accumulated a lot of memory and actually propagated to the rest of the cluster, and it hogged all the memory, and they caused their cluster to crash. If you think about it, there are some workloads that this is their default behavior to accumulate all the memory. Different databases, or for example, a queuing service like RabbitMQ. This is what they do. They accumulate all of the memory in order to be able to serve it for the queuing service. So as you can see, problems may happen to many different companies, and in this case, in the Kubernetes context, it happened to Google, Spotify, Airbnb, Datadog, and so on. And in many cases, the question is not to how do I identify the problem. In many cases, is how do I propagate it to everyone? Maybe I have 100 developers. How am I supposed to make sure that all of them are following the policy that I have? And this is what we're going to dive into now. How do I prevent those failures in the future? And how can I actually build a scalable solution for my policy management? So number one, it is very important to define your policies. So Number one is identify what types of workloads do you have. I'm showing you an example for Kubernetes, but it can be what is your coding convention, what is your styling guide, what is your hardening guide for your Docker files. It can be anything you like. But the number one thing you need to do is to define the policy itself. Number two is to, not all policies are equal. And some policies should run on all workloads, but some policies should only run on specific workloads. So make sure that you define granular policies for specific types of workloads. So you do not end up with a very general and broad policy that should win all cases, but in reality will actually lose to all cases. And this is a crucial part, and you might ask yourself, Shimon, how am I supposed to know which policies I need? So, okay, maybe I have a production outage and something crashes, so then I go and I found out what's the problem and I codify this mistake. So you can use existing linters, you can use solutions that have pre-baked policies. Like in our case, in the trio, we have predefined policies for Kubernetes. You can use, I don't know, other solutions for Node.js or Go, or, you need to find the policies, because I agree, it is like unrealistic to think that you can invent all policies and think of them by yourself. The next thing is that you need to integrate the policies in your organization. So once you have a set of policies, you might send an email to all of your, to all of the developers. Hey, this is our policy. Let's use it now. And I've seen many companies do it. And I did it. It is very naive. This is how you start, but obviously it does not scale at all. And if I think about it, like I'm a developer by heart, right? I've developed for many years. I'm still writing code sometimes. And how am I supposed to remember all of those emails that tell me to use this version or that version and to put in this limit or that limit in place? Like, how am I supposed to remember all of this? And I need some sort of a guardrails, something that will help me do the right thing. Because no developer wants to make a mistake. No one wants to take production down. But what am I supposed to do? So the way to tackle it, in my view, is to validate all changes that are happening in an automated way, and to run it on every code change. So it can be as VS Code or whatever, IntelliJ plugin. It can be a pre-commit hook. It can be something that runs in your CI/CD. I'm a big believer in shift left, so integrate it in your Jenkins, Circle CI, Travis, GitLab runners, GitHub Actions, whatever you like. And I believe in shift left, and the sooner you identify the problems, the easier it is going to fix them, and also it won't take your production down. Secondly, allow your developers to integrate those tests in their local environment, because once they're able to test it and run it, for example, the tree comes as a CLI, right? Or I don't know, take another solution, a linter or sneak security, or I don't know, any other solution. The ability to execute and run it on your local machine, as opposed to only finding issues in runtime, is crucial, because this is how I, as a developer, when developers write code, they do like npm test, go test. So the same thing applies here. You want to test your infrastructure, you want to test your Terraform, you want to give them the tools to be free, so you can delegate the infrastructure as code responsibilities to your developers. And finally, I think that at the end, it's almost inevitable to apply some sort of an enforcement layer onto your CI/CD, because this is the last resort, this is the last gateway. Now, it is for you to decide on which policies do you apply it, on which you do not apply it. I don't know, maybe you did not write a nice README. Should it block it for deployment into production? I don't know. You decide. But Maybe if you do not have a health check in place in your Docker file, or you do not have a liveness probe or readiness probe and so on, maybe yes, maybe we should block it from going to production, because it is a serious problem, because we're not going to be able to make sure and identify that your process or your service is actually healthy. And finally, one thing that is very important is to control and review and monitor your policy. And what do I mean by that? So you define the policy, you sent automated scripts, and you applied it in your CI/CD, and now you make sure that everyone uses it. This is only the beginning. If you think you're done, you've only just begun, because an organization is a living, breathing thing, and everything constantly changes. And you're gonna have to add policies and remove policies and dynamically adjust policies. And this brings us to some of the challenges in that regard, because think of an organization that has 100 or 400 Git repositories. And let's say now you need to actually go and modify it and change a policy in all of your repositories. So how are you supposed to do it? So are you going to open 400 pull requests? You need an automation in order to do the automated test changes. So I believe in dynamically adjusting the policies. And what do I mean by that? It can be a dynamic YAML file that you download from S3. It can be a more complex, a solution that pulls configuration from a centralized state management or configure sets like console or etcd. It can be solutions like the tree that this is what we do, right? We save the state of the policies. We run only in the Kubernetes and Helm states, right? So you can use it only for this. If you want for something else, you need to find other solutions. But for us, when you run the tree CLI, it goes into our cloud and it pulls the most latest policy. So once you want to change the policy, you don't need to change everything in your repositories. All you have to do is to update it in one place, and then it propagates. And I think that for you to go into production with a centralized policy management solution, you must have a way to dynamically configure and change your policy without it being too much of a hassle, because otherwise you won't be able to actually manage it properly. And of course, you need to manage uh, and monitor all of your organizational policy checks. And you need to have some sort of like a tracking, logging, and monitoring. Are we improving? Maybe Bob doesn't get it and it fails 10 times. It's the same policy. Maybe Sally needs help in this area. This can also help you in educating and helping your organization. So, for example, in the tree, you can modify the error message and put in a link to your wiki or some other wiki. And our documentation is educating people on how to do the right thing. And this is also something when you're managing policies in a centralized way for an entire organization, you need to see like what are the trends? Are people improving or not? Are they wasting a lot of time until they're actually managing to pass the policy check? Because we don't want to block people, we want to help people. So let's talk about some solutions. Specifically, my example will be around the Kubernetes area. So we're going to talk about the development, CI, CD, and production places. And I'm going to talk about 3 possible solutions in terms of policy management that you can use: the tree, conf test, and gatekeeper. So Gatekeeper is a policy controller for Kubernetes, and it runs as an admission webhook on top of your Kubernetes cluster. And every time that you perform, you apply some change to the Kubernetes cluster, it will automatically invoke this admission webhook, and it will then run a policy. The policy is written in Rego, which is an OPA, Open Policy Agent compliant language. It will check whether the changes are according to the organizational standards or not. And if they are not, it will actually block the person from kubectl applying this change to the cluster. Now, this is on the last resort. As you can see, it runs on production side. And although it is a nice gatekeeper, as it is called, it is really, really far at the end. And I think we should strive to identify those issues ahead of time. Secondly, we have conftest. And conftest is a solution in which you can write tests against structured files, which is really nice. It can be Kubernetes files, Terraform files, Python files, basically any structured file. And you also write the policies in Rego, and then you run the tests against the structured files, and it will output whether there is an error or not. Same as you do in, I don't know, JUnit or Mocha, Node.js tests, or Python, or whatever, Nose Runner. I don't know, there are so many test runners. any language unit testing that you do, it's basically the same, only for infrastructure as code. And it can be run on the developer's computer and in CI/CD. And finally, of course, we have the tree, which is open source. You can go and see it. It sort of combines all of the above. You can define policies, write custom policies. It comes pre-baked with policies, and the admin can create their own policy and dynamically modify the policies. And it also runs in the CI/CD and in the developer's computer. So in order to look at it, no matter which solution you choose, for example, if you take the tree, it has predefined policies. If you want to use, in this Kubernetes example, conftest and or gatekeeper, you need to write the policies by yourself, or I don't know, find policies in the internet, integrate them into your organization. So you need to have them in CI/CD, pre-commit hook, and in the development area. And finally, a way to control, review, and monitor all of the policy executions. Again, you can build something by yourself by reporting everything, I don't know, to Jenkins, and then combining stuff, or use solutions similar to the tree where we just aggregate everything for you and show you the centralized results. So to sum up, my takeaways from this is, don't trust the default configuration, no matter what the language is or the technology. Define the policies that are right and suitable for your organization, because every organization is its own snowflake. Delegate the knowledge and allow people to make mistakes by themselves, but give them the guardrails to be able to experiment and understand what is the problem and educate themselves. And finally, understand that mistakes happen to anyone, and unless you apply some sort of centralized policy management solution, it is not a question of if, it is a question of when. Thank you very much for watching, and I hope this helps you in managing a centralized policy.